All right, so quadratic equations, still doing the same thing, except we're doing inequalities. So remember inequalities. So an inequality is, get this lined up. So your inequality is going to be your less than or greater than, or I said those backwards, and I didn't even show you what I wrote, so it doesn't matter. You have greater than or less than. Remember, greater than or less than is going to be your open circles or your dashed lines. You also have greater than equal to, less than equal to, and those are going to be your solid circles and your solid lines. And that's because of the line underneath. So, you are going to have to rearrange the inequality so that everything is on the left side and 0 is on the right side. Okay? So you're going to want to rearrange it. You still do it the same way as you would if it were equal. Okay? You're going to solve it just like you would a regular quadratic. And you're going to use the solutions to divide your x-axis into intervals. Okay? So for example, if I have this x-axis over here, you've got negative infinity on this side, you've got infinity on this side. You're going to have your x-intercepts, your solutions, your roots, your zeros. If it's less than or greater than, it's going to be that open circle. Well, we know that a parabola is always going to be this U shape. Now, if it says greater than, so if f of x is greater than or greater than equal to 0, we are looking at everything above the x-axis. So I'd be looking at this. So I'd be looking at the intervals from those x-intercepts up. If it says f of x is less than or less than equal to 0, you're looking at this piece, the information here, because it's below. So you're looking at below. All right. Obviously, you determine the sign so you know if it's opening up or down, if you are coming in from negative, if you're going to positive, all of those things. Now, if you're solving an inequality where it is greater than 0, you're looking at the above, just as I said here in the picture. And if it is less than 0, you are looking at below. So those are the pieces of information that you're going to have to keep in mind. Are there questions? All right, so let's look at the first example. So our first example is already set up for us. 0's already over there by itself. I don't have to move anything around. So the thing I'm going to do here is I'm just going to factor this. So if I factor, I know -4 and -12. A times C is -12. My B is -4. My leading coefficient is 1. What two numbers multiply together to give me -12, but when combined will give me -4? So -6 and +2, because -6 plus 2 is -4, which means x minus 6, x plus 2, and that is going to be greater than 0. So that means x minus 6 is greater than 0, x plus 2 is greater than 0. X is greater than 6, x is greater than -2. So my x-intercepts are 6 and -2. So think about your graph. So you've got your negative infinity over here, you've got your positive infinity over here. I've got -2 and 6. And then, of course, 0 is in between them. So since this just says greater than, I'm looking at everything above the x-axis because it is greater. So starting there, so think about your graph is going to look like this. So I am only looking at everything above. So that means coming in from negative infinity going to -2, and then from 6 on to positive infinity. So I'm looking at all of this and all of this. I am not interested in anything below. So So these are the intervals that we're looking at. Are there any questions? You can also get test values. So you would get a test value to the left, a test value to the right, and a test value in the middle. Like a test value to the left might be -3, a point in the middle would be 0, and a test value to the right would be 7. If you plugged these values in to the inequality here, you could see where you're above and where you're below. But if you know what your graph's supposed to look like, then you can see what you're supposed to be getting information on. All right, the second one is not equal to 0, so I'm going to rearrange it so that it is x squared plus 7x plus 12 is less than or equal to 0. So again, I'm going to factor this because it's factorable. 7 is the middle term, my b. A times c is 12. I know 3 times 4 is 12. Well, 3 times 4, not 3 times 3. 3 times 4 is 12, and 3 plus 4 is 7. So x plus 3 and x plus 4 is less than or equal to 0. So that means x is -3 and x is -4. So this time on your grid, from positive infinity to negative infinity, I've got -4 and -3. This time I'm going to have a solid circle here. And I know it opens up again. So we have a graph that looks something like this. Since this is less than or equal to, I'm looking at what is below. So I'm looking at everything below. So that means the values between -4 to -3. And you will get brackets on those because this is less than or equal to. I am only interested in the interval below the grid or below the line. So do you see the difference between looking at above and looking at below? If you're looking at above, you're going to have that if it opens up. You'll have the union if it opens up, okay? All right. So let's look at this next one. 2x squared is less than x plus 10. So I need to rearrange it so that 0 is on the right. 2x squared minus x minus 10 is less than 0. So it's less than, so I'm looking at below. So let's factor. So I know that my leading number is a 2. My b is -1, and my a times c is -20. My two numbers that multiply together to give me -20, but when combined give me -1. -5 times 4 will give me -20, but -5 plus 4 will give me -1. So check this. Does it reduce? No. So it's 2x minus 5. Check this. Does it reduce? Reduces to 2 over 1. So that means this one is x plus 2, and that is less than 0. Now remember I showed you before, if you change the signs of these numbers here on the side, those are your x's. Those are, all right. So that means that I'm going to take these numbers here. So x is a positive 5 over 2, and x is a -2. So those are my solutions. So if you're looking at your grid, go to your negative infinity to your positive infinity. I've got -2, and 5 over 2 is about 2.5, but we're going to leave it as a fraction. So now I have open circles because it's just less than. It is a positive 2, so it's opening up. So it's basically going to look something like that. And since I'm looking at below the grid, then I'm looking at this interval. So from -2 to 5/2. And these are going to be with parentheses because it doesn't say less than or equal to. So this is the inequality that I'm looking for. The interval for that inequality is from everything from -2 to +2.5. Easy enough? So look at the intervals. All right, this one is all out of order. So I'm going to rearrange it. So I got 3x squared minus 18x plus 27 is greater than 0. Since it's greater, it's above. So we're looking at above. So first thing I'm going to do is realize that the 3, the 18, and the 27 are all divisible by 3. So I'm going to factor out a 3. X squared minus 6x plus 9 is greater than 0. So what two numbers will multiply together to give me 9, but when combined give me -6? -3 times -3 gives me 9. -3 plus -3 gives me -6. Since they're both the same, that means x minus 3, x minus 3. So that means x is 3. Well, if you look at your chart or your graph, there's just a 3. You don't have two sets of intercepts. So that means since this is greater than, I'm looking at above. This is an open circle. So basically, you've just got this parabola that just touches it right there. So if I'm looking at above, well, it's all above, isn't it? Yep. So coming in from -infinity to 3. And then from 3 to +infinity. And that is the interval, which is the whole thing. So since we open up, everything's above because we're just touching the x-axis at one point. Okay, questions? All right. Now this one, all out of order. So we got x squared minus 4x minus 3 is greater than or equal to 0. If I try to factor this, the only two numbers that multiply together to give me -3 are going to be -1 times 3 or 1 times -3. Neither one of those are going to give me -4, so this is not factorable. So that means I have to use one of the other methods from the other day. So I am going to complete the square. I choose to complete the square because the 4 I can take half of. And since I can take half of it, it makes it a little bit easier. So I'm going to do x squared minus 4x plus a placeholder is greater than or equal to. I'm going to move the 3 over and put my placeholder. So remember when you're doing completing the square, you move the number to the right so you can put your placeholder. So now I know this is x minus because it says x squared minus, so my parentheses is going to be x minus. Now take half of this number. What is half of 4? 2, and then 2 squared is 4, and that is my placeholder number. 3 plus 4 is 7. So now I can solve this by taking the square root of both sides and do the square root method. So we're going to take the square root of this, and I get x minus 2. I take the square root of this, I get plus or minus the square root of 7. So your answer is going to look weird on this one, but it's not going to matter because we're just looking at the graph, okay? So add the 2 to both sides. 2 plus or minus the square root of 7. That is a 7. So I am going to... All right. So now if you go over here to your x-axis and draw that so we can draw what this is going to look like. So we have our positive infinity to our negative infinity. So we know that this is greater than, so we're looking at above. So you've got your 2x intercepts because we have 2 plus the square root of 7 and 2 minus the square root of 7. So 2 minus the square root of 7, 2 plus the square root of 7. It's opening up, so we're going to have something that looks like that. And we want above, so we have solid circles here because it says greater than or equal, and I want everything above. So we're looking at all of this. So that means coming in from negative infinity to 2 minus the square root of 7. And we get brackets because it says greater than or equal. And then from 2 plus the square root of 7 to positive infinity. And then remember, your infinities are always going to be parentheses. All right, so this next one here says to solve it. Just says solve inequalities involving a quadratic function. So this page has 2 examples on it. These are 2 special cases. So at the top, you're going to want to write 2 special cases. So 2 special cases, and this is your first special case. So first thing I'm going to do is move the x squared over so that I have a positive x squared plus 2x plus 3, and that is going to be less than 0. So since I am looking at less than, we're looking at below the graph. So if I try to factor this, the only 2 ways I can get a positive 3 is 1 times 3 or negative 1 times negative 3. But neither one of those are going to give me a 2. So I'm going to have to find another way to solve this. I'm going to complete the square again because my middle term is an even number, so I can take half of it. Just keeps it kind of easy. So I know that x squared plus 2x plus a placeholder is less than, I'm going to move the 3 and add my placeholder. So always remember, when you're completing the square, move those constants to the other side. So I'm going to go ahead and put my parentheses with my square. Since it says x squared plus, this is going to be x plus. Half of 2 is 1. 1 squared is 1. So now I have negative 3 plus 1, which is negative 2. Now I can complete this by taking the square root of both sides. So I get x plus 1 is less than. Now, can you take the square root of a negative number? No, because this is an imaginary number. So since this is an imaginary number, that means there's no real solutions. Okay? You cannot take the square root of a negative number. So, no solution. Now let's talk about why. So I'm going to draw the infinity and the negative infinity. So because this is an imaginary, this number right here, this means there are no x-intercepts. So this negative 2, so this means it does not have x-intercepts. does not have x-intercepts. So if there are no x-intercepts, then where is this thing at? So since it's opening up and there's no x-intercepts, that means it has to be floating above the x-axis. Can't be below because it would eventually cross the x-axis, right? So it has to be above. So since it's above, the parabola will never be below. So when you are below. So then what does it mean? What's going to happen? All right, so what's going to happen then when it says x squared is greater? So now it's greater. So now we're looking at above, right? Mm-hmm. Okay, so if we're looking at above, you've got x squared is greater than or equal to negative 9. Well, if I take the square root of both sides, I get x is greater than the square root of negative 9. Can you have a square root? Can you take the square root of a negative number? No, remember this is imaginary. That means no x-intercepts. Well, it's kind of the same thing as the last one, right? So you have your infinity and your negative infinity. You know you're floating up here above, but what are we looking for? We're looking for above, aren't we? Well, if we're looking for above and it's above, then what does that mean? All real numbers will be your solution. And of course, if I could spell. So all real numbers. So make sure you put yourself a note here that the parabola will always be above. So all real numbers. Questions? All right, so just like last time, you got some word problems. So think about, you've got a ball. What comes up, what goes up must come down, right? So a ball is thrown vertically upward with initial velocity of 80 feet per second. The distance s in feet of the ball from the ground after t seconds is s of t equals 80t minus 16t squared. At what time will the ball strike the ground? So think about when the ball is on the ground, what is the height? 0, right? So I'm looking for the x-intercept because if my height is 0, then that means it's on the ground. So I want to know what is x when y is 0. So take your function of 80t minus 16t squared, and I want it to be equal to 0. So I'm going to factor out a negative 16t because negative 16 will go into both of these. Negative 16t times negative 5 plus t. And then I'm going to set each piece equal to 0, just like we did. So negative 16t equals 0. Divide by negative 16, t is 0. So when time is 0, when you start a timer, a stopwatch, you start at 0, right? So negative 5 plus t equals 0. So t is 5. So you're going to start at 0. You're going to end at 5. So that means it's going to take 5 seconds for this thing to hit the ground. So let's draw what that scenario is going to look like. So we throw it up in the air, it comes down. So we start at 0, 0, we end at 5, 0. So now, for what time, so we're looking for the time again, because this is your time, and this is your height. For what time is the ball more than 96 feet above the ground? So more than is going to be greater than 96. So think if this is your 96 right here. I want to know what is the x value for those 2 points. So for here and here, what are the x values for those 2 points? Because this is the part of the graph I want to know. When is it more than 96 feet? So that means, scroll this up a little bit. So I'm going to take my 80, well, maybe, 80t. This thing doesn't, sometimes it acts like it actually has ink. Minus 16t squared. I want to know when it's greater than 96. So if I rearrange it, so I'm going to move the 16 and the 80 over with the 96. So I'll have 0 is greater than 16t squared, because the negative 16 will become positive. The 80 will become negative, and 96 will stay 96, because I just moved everything over with that. Does everybody understand what I did? All right, just want to make sure. All right. I'm going to factor out a 16 because all of the numbers are divisible by 16 so that I'm not having to factor these huge numbers. 0 is greater than t squared minus 5t plus 6. So now I can factor out that. Keeps my numbers smaller. So my leading coefficient is 1. A times C is 6, and my B is negative 5. So I know that negative 2 times negative 3 gives me positive 6 when multiplied, but negative 5 when combined. Take those numbers and change their signs. 2 and 3. So the interval between 2 and 3 is when you are above. So for only 1 second, between 2 and 3 seconds, that's the only time that you're above 96 feet. Before 2 seconds, you're below. After 3 seconds, you're below. Does that make sense? Okay. So to answer the question in words, for what time is the ball more than 96 feet above the ground? We would say between 2 and 3 seconds. So between 2 and 3 seconds. So you're just taking the information you've been doing and you're actually applying it to a scenario. All right, our last one. An arrow is shot vertically upward with an initial velocity of 96 feet per second. The distance s in feet of the arrow from the ground after t seconds is s of t equals 96t minus 16t squared. At what time will the arrow strike the ground? So again, you're hitting the ground, so your height is 0. So I want to know what is the x-intercepts. So when y, so you're looking for your x-intercepts. So I want to know when y is 0. So take your equation and set it equal to 0 and solve. So 96t minus 16t squared is equal to 0. So I'm going to factor out that negative 16t. So that's going to be negative 6 plus t equals 0. Each piece equal to 0 and solve. Negative 16t equals 0, so t is 0. Again, we're starting at 0. Negative 6 plus t equals 0, so t is 6. So we're ending at 6 seconds. So it's going to take 6 seconds. So think about your grid again. Starting at 0 and going all the way to 6 seconds. What comes up must come down. So we are talking start to end. Now, just like before, at what time is the arrow less than 128 feet? So the last problem I looked at being more than, now we're looking at less than, okay? So if we think about this is our 128, so going across, I want to know when is it less than? So when is it less than? So I'm looking at this distance to here. So when is it less than 128? So from here to here. What are the values of x where I am less than 128 feet? So take your equation. So negative 96t minus 16t squared. And I want to be less than 128. So less than 128. I'm going to move everything over to the 128 so that my squared is positive. 0 is less than positive 16t squared plus 96t, and then the 128 will stay the same. Is everybody good? All right. This is supposed to be, well, erase. That's supposed to be a positive 96 because we are following the equation they gave us. So this would be a minus 96 on this side. I am looking at my notes that I already made, so I missed the sign. So thank you. All right, so we moved it over. We have positive 16t squared minus 96t, and then the 128 stays because we didn't move it, okay? Again, all of those numbers are divisible by 16, so I'm going to factor out the 16 so that I can factor this with smaller numbers. So t squared minus 6t plus 8. So now I can factor that instead of that horrendous 128 times 16. Nobody wants to do that. So factor. My leading is 1. A times C is 8. B is negative 6. So I know what two numbers are going to multiply together to give me a positive 8, but a negative 6 when combined. Negative 4 and negative 2. So take those numbers and change their signs. So t is 2 and t is 4. So between 2 and 4 seconds. But remember, we're looking at this interval here and this interval here. So from negative infinity to 2 and from 4 to positive infinity. Actually, it's not positive infinity. It's to 6 because we end at 6. This thing doesn't go on forever. It eventually hits the ground. And this one, yes. I'm looking at the wrong example. And we are starting at 0. So you will have a bracket there because you are starting at 0. And you will have a bracket on the 6 because you are ending at 6. The 2 and the 4 are the ones where you're less than and not equal to. So you are below 120 feet between 0 and 2. You are below 128 feet between 4 and 6 seconds. So that will be your interval. All right, so are there any questions? Everybody's good? All right, I'm going to end.